So again, back to our alveoli, they don't have smooth muscles, but they have these elastic fibers. So I like to think of them like little rubber bands. And so things that when your alveoli and you breathe in and inflate your lungs, your alveoli stretch and they grow bigger. But what's going to make them return to the original shape? If they didn't have these elastic fibers, they would stay open, but how do you actually get them to actually collapse and push things back out? Well, again, this is why these elastic fibers are very important to our function. So you can easily inflate your alveoli by breathing in and causing pressure in your alveoli, but something needs to assist in pushing the air back out. And these are the alveolar sacs. So again, there's little pockets of air, and this is what we have with our alveoli. And this is a microscopic version as well. So notice that you have all this air. These alveoli, they don't have too much bulk in terms of their overall thickness of these cells. And this is where we have to look at the cells themselves. So notice that these alveoli, they're more than just pockets, but they're actually these very thin cells, and they have all these capillaries that run between these cells. So this is how you're actually able to oxygenate the blood. Because you have all this air, now you have a very short distance and all these potential vessels that can absorb this extra oxygen you breathe in when you inhale. Now there are two main types of cells, type 1 and type 2 alveolar cells. This is the Martini version. I think this shows a neat perspective. Oh, and you also have these macrophages as well. At this point, I think we did cover macrophages in PHYL 141. So again, they are a type of immune cell. They are important to the defenses of your body. So this is the cool thing about these macrophages. So again, macro meaning big, phage meaning eat. So they are big eaters. These cells are big eaters, and what are they eating? They're eating debris, or if, say, somehow a bacteria or a virus gets all the way in there, and a macrophage gets to the bacteria or pathogen or before it can enter your bloodstream. This macrophage can come in and then gobble it up and eat it. So this is what's really great about them. But back to our type 1 and type 2 pneumocytes. So the very flat ones, the very flat and thin ones that are broad, these are type 1 pneumocytes. And type 2 pneumocytes, these are the little spiky ones we see here. They're not flat and they're not as broad. But the funny thing is that you actually have more type 2 pneumocytes than type 1 pneumocytes in your lungs. Now, what's the difference? And actually, type 1 and type 2 alveolar cells, I think that's what your OpenStax book says. And type 1 and type 2 pneumocytes, I think that's what the Martini book says. They're one and the same, just different names. So pneumo, again, is a useful prefix referring to anything with the lungs or the air. Now, with type 1, what happens is that notice that they're very broad and very flat. So that's or type 2, that instead of making up the majority of the surface area, they actually secrete a special or substance called pulmonary surfactant. And what this helps to do is break up the water tension in your lungs. Type 1 pneumocytes, if you look at them, very thin and broad, wide surface area, and these are, again, a majority of your total alveolar surface. Again, look at this picture right here. Notice that most of it is covered by the type 1 pneumocytes. But the type 2, small surface area, but despite what the pictures show, they're actually more numerous than your type 1. Now, the thing is that what happens if a type 1 pneumocyte gets damaged? They actually can't repair themselves. So if you have a type 1 pneumocyte and it dies for whatever reason, you can't replace it with another type 1 pneumocyte. What you have to do instead is use a type 2 pneumocyte. So this is how your lungs can have a certain ability or certain capacity to repair itself. So type 2 pneumocytes, they don't not only make surfactant, but they can divide, and they can also become type 1 pneumocytes. So again, even though once you lose a type 1 pneumocyte, you can't divide another type 1 pneumocyte, but you can actually make a type 2 pneumocyte and convert into a type 1 through differentiation.